Here's a shout out for the first edition of Embedded World North America. From October the 8th to the 10th, the embedded community will gather at the Austin Convention Center in Austin, Texas, to experience the regional embedded industry, to connect with industry experts, and to learn about new technologies and expand their network. Join in and get your ticket now for Embedded World North America.
Welcome to Embedded Edge with Nitin, a podcast that brings to life the stories behind today's embedded systems, technologies and products. It's the show where you'll hear from both engineers and executives on some of the most topical news and most pressing challenges in the world of embedded system design. Here's your host, Nitin Dahad.
Oh, hello, this is Nitin Dahad, and welcome to the latest edition of the Embedded Edge podcast. Today I'm talking to François Baldassari, who's a founder and CEO of Memfault. François, hello.
Hi, Nitin. Great to be here.
So, François, tell me, Memfault is a young company. You're founded on some really sort of interesting things you've worked on in the past, but tell us a little bit about Memfault first.
Sure thing. Memfault is a 5-year-old company, so it's about ready to enter first grade. Feels like a lifetime to me, let me tell you. And what we do, simply stated, is we help hardware companies understand how their devices behave in the field. And when they misbehave, we help them understand why. We do this with a little agent, an SDK that gets integrated inside of the device's firmware, sends telemetry data to the cloud through any means of connectivity, even non-IP connectivity, and makes sense of that data so that engineers can look at it and quickly find out when there's a problem.
Tell us a little bit about the background that led to this, because I think that will help tell the story a little bit better as to why this is necessary.
Sure. I often say that Memfault is a startup that happened to me. I didn't set out to start a company. The story is that my co-founders and I worked at a company that some of you may have heard of called Pebble. Pebble was one of the very first smartwatches. And for embedded engineers who are listening, Pebble was a really interesting product because we were building a multi-threaded operating system with a graphical user interface, third-party software you could install on it, right? You could build applications for the watch, syncing all kinds of data to the clouds, all on a small STM32. So it was really a device that I think in some ways we're trying to do computing on a Mac controller. And as you can expect, we had all kinds of issues. People complain about the Bluetooth connectivity. Bluetooth is a complex standards, and oftentimes the phones would implement it in slightly different ways. We had battery life issues. We promised 5 days of battery life and had to do a lot of work to actually meet that promise. But when customers complained, the only tool in our tool belt was to get them to mail the device back to us, crack it open with a hammer and a chisel in the lab, solder in some wires on the leads to get the JTAG out. Exactly. And then we could start doing firmware archaeology.
That sounds so ancient now. That sounds so ancient.
It sounds so ancient, but by the way, it still is how most hardware companies do their work. Okay. And so we thought there has to be a better way, right? We were overwhelmed with customer support requests fundamentally. And being a software company, one that was a Y Combinator startup. Y Combinator is a famous startup incubator. Right. We were surrounded by software folks, and we would ask them, how do you make sure that your software works? And so they shared with us the concept of observability. They shared with us a lot of techniques that they use, but that one really stood out. The idea that you can collect production data and watch the behavior of your software to identify issues before your customers call you. It sounds trivial when you think about it. It sounds obvious, but for us, it was groundbreaking. And so we built this first solution at Pebble. We built a set of tools. I had a wonderful boss, our VP of engineering, who gave me 6 months to do it when I asked. And after we built it, we realized that it completely changed the way that the company worked. So our support team no longer needed to ask 20 questions to understand why customers were calling in. Our engineers could dive right in and fix the most serious problems. And we could even fix problems before customers even noticed them. That was really powerful. And so when we left Pebble, because Pebble got acquired, I actually went to work for Oculus. We found ourselves rebuilding those tools because we'd gotten so addicted to them that we didn't want to work without them. And once we did it a few times, we realized that we wanted to make this available to all of our friends. We kept talking about it with our friends, and they said, "Can I try it?" And we said, "Well, I am doing this at my job right now. I can't give it to you." And so we started working on it first nights and weekends, and then eventually, an investor approached us, gave us some funding, and here we were starting a company. But really, it was something we did for ourselves first and foremost.
Okay, and I think what you sort of mentioned earlier in that sort of description there was having to repeatedly do the same software development again and again.
Right.
And I think that does sort of talk to a certain trend right now. So you might just want to elaborate on this whole open source and some of the hardware software differentials.
Yeah, I talk about this with embedded engineers all the time. So thank you for asking me my favorite questions.
Yeah.
I think as embedded engineers, one of our vice is that we love to build everything from scratch.
Yes.
I think in a way because we needed to. When MCUs were so small that every byte of code space had to be optimized, you couldn't afford standardized solutions because you needed the most custom thing possible to fit exactly your requirements. And so we've learned to build everything from scratch. I've lost count of how many times I've built a linked list library, right? Like basic data structures that no other software engineer anywhere would think of doing themselves. But I think that times have changed. I think they've changed in a number of ways. One of them is that we have many more resources on the devices. The complexity has increased a lot, and the timelines haven't changed. So in order to meet the timelines of shipping products annually or biannually, keep up with complexity, cybersecurity regulation, other constraints from the outside, and deliver the rich interactive experience that our customers demand, we have to build on the shoulders of giants. This is why increasingly I'm encouraging folks to use open source, right? Use Zephyr, amazing operating system, open source, comes with networking built in, a Bluetooth stack, a file system. Like you don't have to build all this stuff yourself.
Yes.
And I also say, some of this infrastructure, like software updates, like observability, you probably ought to find some off-the-shelf solution. It's not differentiated. You have the same need as the company next door. It's very complex to build, and finding the cloud engineers to go build that and maintain it is probably too costly compared to the other things you could be doing with those resources. So that's my pitch. I talk a lot about build versus buy. I think that we should be spending our energy on the things that differentiate our products and working together as an industry to build great open source software and great infrastructure that we can all leverage to build amazing products.
Well, that's the whole principle of open source, really. So you use common intellectual property and then build upon that to actually put your differentiation.
And if I look at the cloud world, like my business is built on open source. I mean, I think that 90% of the software that powers our service is open source.
Yeah.
I mean, just the database that we use is a prodigiously complicated piece of software. If we had to build that ourselves, we'd spend 5 years building a database before we even started building a service.
Yeah. Now, let's come to, the one thing that I think we should probably just keep talking about is this concept of observability. And that observability, you talked about putting SDK onto an agent. And tell us exactly, that customer process, how does that work? I think when we talked previously, I think you talked about how people don't really understand what that observability actually means in practice.
Right. So when we work with a company, I think the first thing that we do is an integration. We have to get the SDK running on their device. This is typically a few days or a few weeks of work where they hook up our SDK with their OS, with their connectivity stack, and with the storage so that we can buffer data on the device when connectivity is not available. We then work with them to figure out what is the signal you care about the most. And at Memfault, we've developed a set of best practices. We call them device vitals. And so the 3 device vitals that we work with today are device stability. So that is for how many hours of consecutive good time, or how long does your device need to run before it experiences an error?
Yeah,
that's what I mean. So in other words, what percentage of run hours see an error versus not, right?
Okay,
so that's product stability, gives you a really good measure of what's the quality of your software. Number 2 is connectivity. How often is your device connected with good signal strength versus not connected at all? And that gives you that ratio, so give you an idea of how well your connectivity is working. For most companies we talk to, connectivity is the biggest headache, right?
Okay.
And then the third one is battery life, which doesn't apply to every device. Some of them are powered directly from the socket, but a lot of our customers have battery-powered device, and they want to know, what's my actual battery life in the field? So when you integrate the Memfault SDK, and frankly, in my opinion, when you do add any observability to your device, you want to be able to answer those 3 questions first out of the bat, because most devices care about those 3 things.
Right.
And getting those answers at the device level is really valuable. So you can pull up a device and say, what was this device's connectivity? What was this device's battery life? But also getting them at the fleet level is really interesting, right? And how do those numbers change from version 1 to version 2 of my software? Really, really good questions to ask so that you can start reacting if there's a problem. The other thing that we'll do, the last thing that we'll do, is we'll look at your specific product and work with you to say, what's the signal you care about? Right. So, for example, one of our customers, Latch, which is a lock company, they make locks for commercial, for big residential real estate buildings.
Okay.
And they're Bluetooth connected, and they have all kinds of reporting built in, very beautiful devices. For them, they care a lot about how often do the locks get locked and unlocked, and how much, how much, strength, power does the motor require to turn? Is it sticky? Is it not sticky? Like, these are things they care about.
Yeah.
And they have a lot of Bluetooth, because they are very limited Bluetooth connectivity. The device only connects while you walk through the door. It connects to your phone. Okay. So they also kind of measure how many bytes of data they were able to get out during when a user walks through. So those are things they care about. But you might think about another one of our customers is AirThings. They're air quality sensor for factories and offices and things like that, and they might care about the temperature of the device. They might care about whether the sensors themselves are working properly. What's the raw signal that's coming into the ADC, so that they can debug that, right?
Yeah.
And then we work with them to grab that signal and build dashboards that they can use. And ultimately, success for us means we want to hear our customers come to us and say, this product is the most reliable product we've ever built.
Yeah.
And it's the one our customers are happiest with. And by the way, I've heard that exact sentence, which, that makes it all worth it for me.
Now, I think one thing that doesn't come out there is really, I think from what I can see, is the immediacy of getting information, as opposed to what you talked about earlier, which is sending the watch back, tagging in with a J. And I think, when you have an expectation in this world of IoT and connectivity of a quality of service, and where people are selling something as a service, then you need to know straight away, as opposed to having something being sent in. Is that an issue? Right.
We've seen over the past decade a big shift in the business model of IoT. I think, when I think back about Pebble, at Pebble, we hadn't figured out the business model of IoT. That's one of the problems we had as a business, I think, which is that we were still selling devices for margin. So we sold a watch, we made some amount of money, some dollars every time we sold a watch, and that was it. Yeah. But we had this huge software business on the software cost on the back of that was ongoing forever. So that that wasn't a very good business, all things considered. But if you look at our customers today, overwhelmingly, they have some sort of services business or software business layered on top of their hardware. So, an example is Whoop. Whoop is a customer of ours. They're a fitness band, but you may not buy the fitness band without the subscription. In fact, they don't even sell the fitness band. When you buy the fitness band on Amazon, what you're buying is a year of subscription upfront, right?
Okay.
They just give you the hardware. The hardware is a mechanism for the service. And so what happens when you're a service business rather than selling a device once and done? It's all of a sudden, if the device stops working perfectly, that becomes churn. Like you start losing revenue. Your customers stop paying you. And that you care about a lot. And so these companies are constantly looking to optimize quality and reliability, because if they can keep the device working just a little bit better or a little longer, that's more revenue they can make. And that's really valuable to them. So I think this is a big part which has changed the view on observability. When observability, if you think about a company like Pebble, observability is an ongoing cost against a fixed revenue. So it would be difficult to justify. But when you have ongoing revenue that you want to protect, I think all of a sudden, building infrastructure, building observability, thinking about sustaining in a more holistic way makes a lot of sense. And doing it one device at a time in the lab or by sending technicians is really expensive. The other thing, Nitin, that I think you'll probably relate to is that the users rarely actually contact you. You oftentimes have users, the device doesn't work. They're like, okay, it doesn't work. And they just stop using it. They don't bother to mail it back to you. They just stop using it. And so the nice thing about observability is it actually tells you not what the most vocal people are experiencing. It tells you what your average users are experiencing. And that's what you actually ought to care about.
And does it also lead to a bit of proactivity from your customers that they can see when something's wrong and then do something about it?
Exactly. You can be proactive rather than reactive. And you can even, the dream is you start a software update and you only update 5% of the fleet because you've built a stage rollout system. We have one of those for what it's worth. And at 5%, you watch the data and you see, oh, wow, our connectivity actually decreased. Our devices are not connected as well as they used to. That's really interesting. We investigate that. You pause the rollout so that no other customer gets affected. Then you fix the problem, and then you push it to the whole. You push the rollout to the whole fleet after you've validated it. And now, you've got thousands or tens of thousands of customers who are not experiencing the problem when they would have in a previous mode of operating.
Well, we've seen that, and won't mention it here, but in a certain other big outage that we've had recently. Yeah, also, I think it's also useful to have that ability to be proactive, and I think that's actually quite important, and that's why observability is probably key there. Now, you did mention a few customers there. Were there any others you wanted to identify, or are those sort of good examples of how they're doing things?
We have a number of customers. You can see them on our website. I'm very proud of working with all of them. I'll tell you a couple that I think for me stand out. One of my favorite customers is a company called Panic.
Okay.
They're not huge. You might not have heard of them, but they make a little handheld game system called the Playdate.
Okay.
And why do I love this? First of all, it reminds me of the Pebble so much. It's an STM32 running but you can write little Lua application on it. I think it's one of the bigger, STM32s, has a good amount of memory, has beautiful industrial design, and the games are wonderful. I'm a customer of theirs. I actually like to buy most of our customers' devices. So I have a lot of devices in my home. It drives my wife crazy. And I love the Playdate because it's such a sophisticated device, and observability for them is so key, right? They can identify games that don't work well on their device. And they can go and fix them without having to get in touch with the developers themselves, right? I think that's really cool. I also really like our customer Bond Home, which is I like them because they were such a sophisticated team in the first place. They make a bridge box that basically can connect your ceiling fans or your AC units to your Wi-Fi. It's quite a big business, actually. Here, like, connectivity is key. They have multimodal connectivity in the box, coexistence issue, and getting to the bottom of all of the Wi-Fi or Bluetooth issues that come up is an endless game of whack-a-mole. So getting observability for them is really key. And in fact, so much so that they had built an observability stack in-house before they ended up working with Memfault. So they were really forward-thinking. They built an observability stack in-house, ended up moving to Memfault because it's cheaper than building your own stuff. And our capability was better, and they were able to knock out so many of these connectivity issues, and their device works amazingly well now. So those are two that I'd like to talk about. We have many other companies that I really enjoy working with, but people can go. I won't tell all the stories. I'll let people go on our website and check out the case studies.
But all these things. So does that not lead to some potential concerns about sort of privacy and security if you're sort of observing all of this data?
So those two things, I think, require separate answers: privacy and security. So first, let's talk about privacy. Privacy is super important, and especially increasingly, it's not just something that you should do because it's the right thing to do. It's something that you should care about because the regulators really want you to, right? And especially in Europe, where you have GDPR.
Yes.
And so what do we do to maintain the privacy of the end user? I mean, ultimately, first and foremost, we work with our customers to focus not on the user, but on the device. So we don't collect any information about the end user, except the information that we incidentally collect by observing the device itself, right? That's the first thing. Second of all, we have put strict controls in place internally. We comply with the GDPR. We've signed very, very strict contracts with our customers that explain the things that we are allowed to do with the data, the things our customers are allowed to do with the data. And I think it's worth saying that our customers retain ownership of the data. We don't have the ability to use it for anything other than provide our service of diagnostics. The third thing I'll say is that our customers choose every single data point they collect. So Memfault doesn't collect data points unbeknownst to anyone. Our customers choose every single data point they collect, and they know the privacy and security requirements of their end users and make those decisions in consequence. So it's very important to us that our product not be used to spy on people. We make our customers tell us that promise that they won't. I'll talk briefly on the security piece.
Sure.
First, we're certified in every which way. In the US, the big certification is called SOC 2 Type 2. We're certified that way. Everything's encrypted, everything, we follow best practices, but that's not all of it. The other thing is actually, I believe that observability can help us improve the security posture of devices. Oftentimes, devices get compromised, and because there is no observability, no one ever knows that a device has been hacked or compromised. Yes. And I believe that being able to observe the behavior of the device, for example, observe how much network traffic a device is sending and receiving, can be a huge, huge improvement to the security posture of these devices. And so we think that actually Memfault is hopefully part of the solution of securing the IoT rather than an additional problem. Yeah. But of course, that's I'm biased.
It's true because if you see a surge or if you see a certain pattern which you observe is not right, then I guess that identifies some potential something is not right. It's not right. Yeah. What are the things that you think what you're doing with customers, and what do you think customers don't yet fully understand, or you find it very difficult to convey because it's a misconception?
I think the main thing that comes to my mind immediately as you ask this question is I think most hardware companies have not yet taken stock of the fact that they're becoming software companies.
Okay.
If you look at, I had some very interesting conversations. We're partnered with some of the largest semiconductors in the world. And I was just talking to someone that I won't name them because they haven't authorized me to relay this story. But but I don't think it's too sensitive. And they told me, 3 years ago, we tipped into having more software engineers on staff than hardware engineers. A semiconductor, right?
Yeah.
That makes Mac controllers. I look at our customers, and that tipping point has actually been hit a long time ago, right? If you look at a company, your average consumer electronics companies nowadays, they have sometimes an order of magnitude more software people on staff than they have hardware people. And yet they're so used to working a certain way, and their identity is really tied to the fact that they're a hardware business. And so they still do things very differently from all other software companies. And so when I meet some of the executives at these companies, I ask them, if you were a software company, what would you do differently? And that change in framing helps them think about business differently in abstract. And then if I tell them, well, aren't you a software company? And of course, that's challenging for them, but it's a good area of exploration. Now, I will tell you that this is a very controversial thought. And in fact, I remember reading a blog post last week about by an automotive engineer, a guy who's been building automotive software for 20 years, really experienced guy. And he said, like, automotive is not IT. We're not a software business. You can't bring your, software practices to our industry. That won't work. We're too safety critical. We're too unique. We're too different. And respectfully, I disagree with that. I think that hardware is becoming a business where software takes an increasingly large piece. In my opinion, the largest piece, actually, of the value we're providing. And therefore, we have to learn from the software industry how they manage to build such reliable things when they do, right? When you type google.com in the search in your browser, it always shows up. The search bar always appears. Yeah. Why? Because they've learned how to build reliable software. We can learn from them. And instead, what we're doing is we're building insulin pumps that injure people because there's a software bug in them, right? As happened a month ago, 400 people injured. So we have to learn, this is I'm getting a little bit agitated here. This is one of the things I care about the most is we have to manage that transition and build more reliable software.
I think so. The customer sort of misunderstanding is, that they don't really understand what their business is.
Exactly.
Okay. All right.
It's transformed from under them, right? Yeah. It used to be they had to be really, really good at manufacturing and logistics and supply chain and integrating these different hardware components together. And now they have to be really, really good at software. That's where most of the value is. Okay. And that's a fundamental transformation that has to change their business models, has to change their staff, has to change how they operate, what tools they buy, how they market their products, and many other things.
And I mean, one of the other things I think I remember you mentioning in the past is that many companies actually think their product is working fine and they don't need observability. Do you get that quite a lot?
That's maybe on the other side of that, that's the least favorite thing that I have to talk about all the time is, I feel like it is a very uncomfortable conversation to have with someone to tell them, no, you're wrong. Your product sucks. You know what I mean? No one wants to hear that. But when I meet with folks, a common objection I get is like, our product works okay. And it turns out when I ask them, I say, oh, great. How often does your product crash in the field? And they say, I don't know. And so I tell them, well, is that a problem? Should you know? And so inevitably, when we end up working together, I like to ask them, okay, how often do you think the devices crashes in the field? By the way, crashes are not the only measure of quality, but it's an interesting one. And I always get the same answer. My devices crash once a month. It's for some reason, that's the universal answer. That's what people think is good enough, right? And the reality is they have no idea, actually. And so we ship an update with our SDK. We start collecting the data. And in my experience, the best ones collect a crash once a week. That's kind of as good as it gets. Yeah. Most of them, it's in the once a day to once an hour range, right? Yeah. I mean, really astounding, actually. So there's a big disconnect between people's perceived quality of their products and the actual quality of their product. And I think in large part, it's because the engineers, first of all, have no data, but more importantly, are too far removed from the customers. Like, ask any embedded engineers, how many of your devices are returned every year? Or how many customers contact support every day? And they have no idea, right?
Well, there's a couple of stages removed, so begin down the value chain.
Too many stages removed.
So,
and they don't have observability, so they have no data for themselves. So, of course, for me, that's challenging because I'm trying to sell tools to make device more reliable. And if you think your device are reliable enough because you don't have any data, well, that makes it tough for me.
Okay, let's try and sort of close on this. So, what's your key sort of message? What do you think is right or wrong, or what do you think people should be thinking about?
I think in looking ahead, people should be thinking about how they make their software a part of their reliability strategy. Companies have gotten amazing at building reliable hardware, and we've taken that for granted now. But even 50 years ago, cars were very unreliable. We've learned how to make them very reliable. I think now that software takes an increasingly large part, we have to come up with an integrated quality strategy that helps make that software just as reliable as the hardware we've been building for decades. I think that this should include observability, but certainly that's up for debate. What isn't up for debate is that there is a reliability crisis in embedded software, and we have to take it seriously and deploy the same level of rigorous engineering that we have deployed to make, metals very reliable and silicon very reliable and all of these different components very reliable.
Well, François, thank you very much.
Thank you, Nitin. This was wonderful.